Yes, good morning. We will be continuing with yesterday's discussion. Yesterday, I think we stopped at a point where we tried to insert the first ever node in the linked list. I hope my audio is clear for you. Please let me know. Okay, voice is breaking. Fine, I'll stop the video. Okay, now my audio is clear so that I can proceed ahead. Yeah, thank you. So let's begin with, or let's continue with the things that we discussed in the yesterday's class. Probably we stopped at this point when we were discussing about writing a program of insertion of a new node in a singly linked list at the rear end. Okay, so this is a point where we stopped yesterday. We were talking about creation of a node using create node function, then putting the element to be inserted at the info part, then the link part getting filled with null. Okay, this is where we stopped, and next we talked about when first is null, my temporarily created node becomes the new first node of the linked list. Okay, so I will write a comment for this. If the element is the first ever element, first ever element to be inserted, then what will happen? The temporary node that is getting created, that itself will become the first node. Either you can do like this, or very well you can go ahead by doing first is equal to temp. If you do this way, first is equal to temp, there is no need of returning any node. Okay, there is no need of returning any node. Okay, so we had stopped at this point. I hope up to this point there are no doubts so that I can proceed ahead. Please let me know. I will proceed ahead if no doubts. Let me know, please. Yep. So I will proceed ahead. So the second condition talks about if linked list has already elements, either one element or more than one element. In any of the cases, I have to do this. I have to do the following. Okay. So before I start writing the program, let me just go back to this point. Let me just go back to this point and I will just run the slide. Okay. Now, you just assume that initially first was null. Now I have inserted a temporary node. That temporary node itself has become the first node. Okay, next time when I want to insert a new node, okay, when I want to insert the new node, for every time, I need to go in such a manner that the temporary node is getting attached to the link part of the last node. Be it only one node available, be it more than one node available, at any point in time, I have to talk about linking the link part of the last node to the new temporary node that is getting created. Okay. Now, when I have at this point, you just assume I have at this point something like this. Okay. How this goes on? First, getting replaced or getting aliased by what is called as current, and I need to proceed in such a manner that I have to reach the last node. Until current becomes null or current not equal to null, I have to repeat this. I have to repeat this. So, be it a single node, be it, suppose there is exactly one node. There is exactly one node. In this case also, when I want to have a temporary node that got created, that need to be attached to the first node, and the next node, the temporary node, becomes the second node. In this case also, I have last node which is acting as the first node. Okay, so in any of the cases, if I have one or more nodes, I should take what is called as a current node, which is pointing to the first node, which is pointing to the first node. So when I have an alias created, that current will move in the direction until the current becomes null. Okay, guys, please tell me, if I write, if current arrow link not equal to null, or while current arrow link not equal to null, or when I write while current not equal to null, please write down both of these. Please write down both of these. While current not equal to null, this is the first condition. Second is while current arrow link not equal to null. How these two, how they are differing? Will they actually differ? Please let me know from your end. Okay, let me just write it for you. So have you written this down first of all? So how these two are different or both mean the same? See, this can be analyzed by taking this example. Suppose that I have taken current at this point. Okay, this is also acting as current. This is also acting as current. Now, okay, now what happens? While current arrow link not equal to null. So in this case, whether current gets incremented or not. Current arrow link is not a null, so current will be definitely incremented to the next node. Yes or no? Please comment, guys. I'm waiting. I have been waiting for your comment. Please comment. Yes, thank you. Now current gets incremented and it comes at this point. Over here, current arrow link not equal to null. It is also true. So again gets deleted and current moves to the next node. Okay. At this point, current arrow link not equal to null fails. So current stops at this point. We'll take the second one. So the first one, what it does? It moves the current to the last node. Up to the last node, the current gets incremented. I'll take the second one. Please note the difference that is there. Second one talks about current not equal to null. Okay, until current not equal to null. This also talks about incrementing of current until current becomes null. It means what? Current will point to the last node until the last node. Next to the last node, the loop continues. Okay, this also does the same thing. This also does the same thing. But the second one talks about when I want to reach the last node, when I want to count the last node also, then I will go for this. So at the end of the loop, can anybody tell me where the current will be pointing? The second one I'm talking about. at the end of this loop where current will be pointing. Let me just write 10 here. Okay, and I will write 20 here, and I will write 30 here. You just imagine that this is the current situation of the linked list. I have not added the new node. You just assume like that. At this point, if I apply this while loop, where current will be pointing at the end of the loop? Will it point to 30 or will it point beyond 30? How can it be 20? Okay, let's just start off. Current not equal to null at the initial stage. Definitely it is not null. So, where current will go? Current is not equal to null. Then current equal to current arrow link. So, current moves to the next. Okay, it moves to the next. Whether current is null now, still it is not null. So what happens? Since it is not null, current equal to current arrow link moves to the next. Current right now is pointing to 30. Current not equal to null, true. So where it moves? Moves to the current equal to current arrow link. And what is there current in the current equal to current arrow link? Null. Okay, beyond the 30, node 30, current is null. What is current arrow link? It is null. Okay, so current will be pointing to null. Then it goes back. While current not equal to null, true it is. It is not true. Current is null. Null not equal to null fails, comes out of the loop. So when you want to include the last node also, you want current to go beyond the last node, then I will use the second set of operations. When I want current to point to the last node, I'll use the first set of statements. So when I use these set of statements, this condition, current will point to the last node. When I use this, current will go beyond the last node. So this part, second part which I have highlighted, it is useful for me when I am talking about displaying of all the nodes in linked list. Yes or no? When I want to address every node until the end of the linked list I reach, I'll use this kind of loop where I want to address every node and I want to reach beyond the last node. Any doubt at this point, please let me know. No more doubts? Okay, there is a question whether the current increments with each insertion. Insertion or deletion, whatever you do, current is local. Once you call that current is nowhere useful outside the function. Once you use it, one time it is useful. Next time when I call insert, current again begins from first. Current again begins from first. What is important for me? From where I have to start. That is important. And who holds the starting point? Starting point is held by first. Current always will begin from first for every insertion. I'll show you when I complete that program. When I complete that function totally, I'll show you that. Okay. Shall we continue with the program writing? Please let me know. Shall we continue with the program writing? Whether the explanation is okay for you. Yes. Now, if I want to reach the last node, If I want to reach the last node and I want current to point to the last node, what should I write? Do I need to use the first set of instructions, first while loop, or do I need to use second while loop? What is more convenient if I want current to point to the last node? First while loop or the second while loop? Second loop will point current beyond the last node. Praveen, this is what I explained. I want current to point to the last node, not beyond the last node. Correct. It is current arrow link not equal to null. So before I could do that, first thing that I need to do is I just have to have declaration of the current node. So what I will do, comma, star current. Okay, next what I will do is I'll write current is equal to first. This is simple pointer assignment. No star is useful when I'm doing two pointer assignments. Okay, then while current arrow link not equal to null. I have explained it before. Please have a look at the thing that I'm writing. I just want current to point to the last node before I can insert the new temporary node that I have created. So at the end of this while loop, current will point to the last node, first will point to the first node. After this loop has ended, current will be pointing to the last node. So let me write that comment. At the end of this loop, current will be at last node. Okay, now next what I need to do? I need to assign the temporary node that got created. Temporary node that got created, I have to assign that to the end of the list. Who is holding the last node's address? Who is holding the last node's address? Comment quickly. Who is holding the last node's address at this point? Who is holding the last node's address? Current. Yes or no? What about others? Who is holding the last node's address? It is the current. And I need to attach the temporary node which is already created in these three steps to the end of the list. So how can I attach the temporary node to the end of the list? What is the way out? How can I attach the temporary node that got created to the end of the list? Can anybody comment? What is the statement that I need to write here? Okay, Praveen, yeah, all of you are commenting correctly. Current arrow link equal to temp. So what is the meaning of this? Current arrow link is equal to temp means currently current is holding the last node. Its link part was null, but now I am overwriting that null by the temporary node. And temporary node has the new element to be inserted. Along with that, it has a null in its link part, which is very well taken care. Null at the link part of the temporary node talks about having the dead end of the list. It's so good. So the temporary node will become the new last node. It will become the new last node. Be it anything you are inserting at the rear end or at the front end, whatever it is, you have to return first. Why you have to return first? Because there is a return type. Since this return temp is for if, it is for if. For the else part also there has to be return because there is a return type. Are you getting this point or no? Any doubt at this point? Please let me know. Any doubt? If no doubts, I will proceed ahead. Can I proceed? Yes. So this is the overall function of insert rare. How this works. Let's check. Okay. We will bother about display afterwards. You just assume that first is null initially. First is null initially. So definitely user has chosen 1 as the choice. It has entered into case 1. In case 1, I have entered the element as 100. I've entered the element as 100. Please note down, right now first is null. Go on doing in a piece of paper, then you will understand this. Okay. Now, insert rare of first. What first contains? Null, comma 100. Element is 100. So, null and 100 gets passed. Okay. Goes to the function part. First here receives what? Null. And E receives what? 100. Enters the function. There is a creation of new node. Okay. Temporary node gets created. Its info part gets filled with 100. And temp arrow link, temporary nodes link gets filled with null. Now, condition gets checked. First contains what now? Null. Null equal to null, true, enters the loop. And what happens? There is a returning of address of temporary node. So it goes back to the caller. The caller contains receiving variable. Who is receiving? First. What it receives back? Address of temporary node. So first gets overwritten. Previously it was null. Now it gets overwritten with the address of temporary node. So first, let's suppose has received back 1000 as the address. Okay. Next time, there is infinite loop. Okay. User is prompted again. Enter your choice. I have entered 1 again. Now insert rare of. First gets passed with 1000 because 1000 is the address of the first node. Element suppose I have read as 101. 1000 and 101 gets passed. Okay, goes back to the function. First receives 1000. E receives 101. Now, temporary node gets created and info part gets filled with 101 and temporary node's link gets filled with null. Afresh the things will happen. Afresh. Temporary node now is pointing to 101. Okay, then the condition checking. What first contains? 1000. 1000 equal to null, fails, comes out of the if. It goes into the else part. What is there in else part? Current equal to first. Current and first both will point to the same address 1000 now. Okay, now while current arrow link not equal to null. What is current right now? 1000, that is the 100. Element 100. That node is pointed by current. And it is the only node that is available. Current arrow link, is it null, not equal to null? Fails. It is null because there is exactly one node. There is exactly one node. 100 and null is available. So while loop never gets executed. It comes out of the while loop. What is there in outside the while loop? Current arrow link is equal to temp. Current arrow link, that is 100 nodes link gets linked with temporary node. What temporary node contains? 101 and null. Now the linked list contains 2 nodes. 100, 101, 101 ended with null. Return the address of first. Nothing doing here other than returning the same old address. What gets returned? 1000. Why this statement is required? It is just because there is a return type. Okay, so next it comes back to the same caller. First returns with 1000 again. No, nothing wrong in returning the same address. Now user chooses 1 again. Now the element inserted is 102. 102 and 1000 gets passed. Okay, goes into the function. First receives 1000. E receives 102. Temporary node gets created. Element E, info part of the temporary node gets filled with 102 and temp arrow link becomes null. First, whether it is null? No. It goes out of the if. And current points to 1000 now. That is 100, node 100. Now, while current arrow link not equal to null, please note there are two nodes right now, 100, 101. Okay, 102 is independent node that has been created that needs to be attached. Now, current pointing to 100, whether current arrow link is equal to null, it is not equal to null. So, the while loop's condition becomes true and enters the loop. What happens? Current is incremented by one node. Now at this point, current is pointing to 101. Goes back. Current arrow link not equal to null. Null not equal to null fails. Current arrow link is null because the second node is the last node right now. So at the end of this loop, current will point to 101. Then current arrow link, which was null previously, now gets overwritten with temp. This is how the things are taking place. Any doubt at this point? Any doubt at this point? I'm asking you 100 times probably. Any doubt at this point? No doubts? Okay. So, shall we proceed to display? Display, it is the simplest part of the program writing. Can anybody tell me what should I do for the display function? I will take the second while loop because I need to consider the last node also. Okay, I'll consider the second while loop, and instead of only incrementing current, I'll do one more thing. What is that? I'll write something like this. Can anybody tell me what should I write before incrementing current? Yes, can anybody tell me? Why do I require counter variable? I need to display, that's it, Praveen. To display anything, what is the function that I'm using? My display function should contain, yes, I'll give one more minute of time. What should I write? The display function. Say, I don't require anything here. Okay, to anything to return. Ananya has commented printf %d/n, comma current arrow info. Correct. You're right. So let me write void display underscore SLL of, definitely I require struct node star first. Okay, and then I will take struct node star current, which is assigned to first. Then while current not equal to null, I'll simply write printf %d comma current arrow info. Okay, every time print the info part of the current and move to the next node, something like this. Let me just check. Initially current is pointing here. Okay, let me just drag this. Initially current is pointing to first. So what I will do, while current not equal to null, current is not equal to null definitely, so it enters the loop. Inside the loop, what is that I have done? Print current arrow info. Print current arrow info. So what gets printed? Current's info part is 10. 10 gets printed. Then increment current. Current gets incremented. Current is equal to current arrow link. So it comes to the next node. Current not equal to null. True. Enters the loop. Print current arrow info. What gets printed? 20. And increment current to next node. Current equal to current arrow link. Okay, at this point, current not equal to null. True, because current is having an address. Enters the loop. Print current arrow info. 30 gets printed. Increment current. Current equal to current arrow link. It comes here. Now, goes back and checks again. Current not equal to null. Current is null. So it will never enter the loop. 10, 20, 30 all are getting printed. So this is what I need to do in the display function, and I don't require anything else other than the starting point of the linked list. So display requires the address of the first node. So accordingly, I have done the same thing. And other than this, for empty list, I have added one condition. Okay, current equal to first I have taken. If first is null, what is the meaning of it? Empty list. And I have written simple return. Even though you have a void as a return type, simple return will return back without any value to the caller. Okay, then otherwise, if first is not null, this condition is for, basically it is for empty list. Okay, if empty list, I need not display any elements of the linked list because it doesn't have. Okay, otherwise, if not, current not equal, while current not equal to null, printf %d, I have given an arrow just to indicate the link. Okay, current arrow info, and increment current until the end. And at the end of this loop, I have simply printed null in order to tell that explicitly. This is not mandatory. Okay, in order to tell explicitly that I have reached the dead end of the list, this is done. Okay, now with these things, let me just run this code. Okay, insert rare, I'll choose 1, element to be inserted 100, insert rare again 101, insert rare again 102. Okay, now I'll display choices 2. Just have a look at this. 100, 101, 102. Since I have printed explicitly null using printf, it has printed null. Okay, any doubt at this point? If no doubts, I will ask you a question. Are there any doubts for you guys? Okay, no doubts. If you are keeping quiet, it means there are no doubts. Okay. Now, if I want, every time I insert a node, it has to print me how many number of nodes are there in the list currently. What is the way out? If I want you to print every time after insertion, how many nodes are there currently in the linked list, then what I am supposed to do? Yes, can anybody comment on it? Where I need to increment count, Praveen? Where? Okay, after every insertion, where? Should I do it as part of main or should I do it as part of the function? In switch itself? Okay, let me take something like this. Let me take comma count equal to 0. Okay. Now what I will do? After I have called count plus plus. Will this be okay? And I will write printf number of nodes equal to %d/n, comma, count. Okay, let me just run this and let's just check it. Enter the choice 100. Number of nodes right now is 1. Insert again 101. Number of nodes is 2. Okay, so this is working. Now if I want to have count of nodes to be done as part of the function, how should I supposed to do? Simple. You just have to pass it as an argument, and inside the function after insertion you have to increment the count. Okay, and when you are passing you have to pass that as pointer, because the thing that is getting modified, that also has to get reflected in the main, so I have to pass it as a pointer. Okay, let's just get away with all these things, and now what I will do is I will give you one function which is called as insert front. Okay, if I ask you to insert the new element to be inserted at the beginning of the list, not at the rear end of the list, it means what? I have to do something like this. Suppose, okay, now what I need to do is, at the initial stage first will be null. Initial stage first will be null. After inserting the first ever element, temporary node itself will become the first node. The first condition remains the same. Now let's suppose I have already an element 10. Okay, there is a null. It means there is exactly one node in the linked list. Now I want to insert 20. There is a new node created using create node function, similar to create node function. I have created one new node which is temporary node. Okay, temporary node. This temporary node has to be the first node, and the current first node has to become the second node. What is that you are supposed to do? Can anybody try this out? I'll give you 2 minutes of time for writing the code for this. Can anybody try this, please? And I will wait for your answers. I want to insert a new node every time at the front end of the list, not at the rear end of the list. How you are supposed to do? Okay, I'll explain it for you. The link for part of the temporary node always has to point to first node. Yes, Ananya, temp arrow link is equal to first. Correct. If you write a temp arrow link is equal to first, whether the first remains first, so I'll just go back to the program, and if I want to write insert front, okay, let me just add one more. Let this be 3, let exit be 4, okay, let 2 be insert front. Yes, I'm just editing the thing. Okay, I'm just editing the thing. What is that I have added? I have added one extra feature or one extra operation on the linked list. Insert front. So case 2 now will become case 3 and case 3 will now become case 4. Okay. Then I need to write case 2 again. What is that case 2? Case 2 is insertion of the node. Okay. So I'll just copy this because the same thing I have to write. Printf enter element to be inserted at front. Okay. Read that element and call insert underscore front underscore SLL of, definitely I require the current first and I require the element to be inserted. Then I'll write break. Okay. I'll just go back and copy until this point. And I will write the function name as insert underscore front underscore SLL. Okay. Then it requires the address of the first node and also it requires the new element. Okay. Inserting at the front end of the singly linked list. Now insert underscore front underscore SLL. Now what is that I need to do? If first equal to null, this remains the same. I have to write return temp. Okay, when I am writing return temp, struct node star will be there. So here it will be first is equal to. Okay, so I'll go back to this. Next, if not first node, not first ever element. If not first ever element, then what I am supposed to do? I'll write current is equal to first. This remains the same. Or I don't require this. Can anybody tell me what is that I need to write? Ananya has commented temp arrow link equal to first. Temp arrow link is equal to first. I'll just go back and show you. First is right now this temporary node got created. Temp's link has to be first. Okay, temp arrow link is equal to first. Now, for the next time, 20 has to become my new first node. So what is that I need to do? Can anybody comment quickly? I am left out with only 2 minutes. Can anybody comment? I need to overwrite the first node with the new address. How I am supposed to do that? Yes, no answer? Every inserted element is shown as first node. You are right. Yes, Srinivas. You have to show every inserted node as a new first node. Then how you are supposed to overwrite that? Yep.
Instead of assigning temp as first, ma'am, like going backward, ma'am,
Hmm?
we use the first as the ending condition, ma'am.
Okay.
Like the temp attached at the last, ma'am, in the last
Hmm?
will be the first element, ma'am. Will be considered, ma'am. We will not assign it anything, and
Hmm?
the ending condition will be written as current not equal to first, ma'am. Can't we go with that, ma'am?
That becomes complicated. Actually, this is only 4 lines of code.
Okay.
I'll write return temp. So what will happen? Who is receiving? Who is receiving?
First, ma'am.
First. So first gets overwritten with the address of the temp every time.
Oh, yes.
Okay. So you are overwriting the first with new temporary node that got created because every time you are inserting at the front end. This is the simplest function that is available. Okay. Let me just save this and run. I'm left out with only 2 minutes, I think. Today's your task is, okay, let me just continue this. Choice 1, let me insert the first element, say 100. Okay, then let me insert at the front end of the list and let me write 50. Okay, then I'll write display. So 50 and 100. If I want to insert once again at the front end of the list, 25, display again, 25, 50, 100. Now if I call 1 and let me insert say 150, it will insert. See, there is a bug in the code. Number of nodes is equal to 2 it is showing, but